Okay, last part for 5.05. You're going to get a lot of questions that look like this. Hey, they talk about a parent quadratic or a parent function or parent graph. So the parent function, I like to think of it as like no frills, the most basic type of function. So for a quadratic, the parent function is f of x equals x squared, the one most basic parabola. Vertex at 0, 0, opening upward, normal steepness. So it says, hey, how does this graph compare to this graph? Well, okay, let's take a look. They are doubling all the x's. So the first thing they're going to do is double all of the x's. Okay, well, if they're doubling all the x's, that means all of our x's only have to be half as big as they were before, because the first thing we're going to do is double them. What that does is it forces all of my x's, instead of looking like this, all of my x's are twice as close to the y-axis. Everything is compressed. So it actually looks like this graph here, the red graph. Everything is compressed. It's half as far from the y-axis that they used to be. All of these points are pushed in. So this is a horizontal compression. It would be a horizontal stretch if it was something like 1/2 x squared. Oops, 1/2 of x and then square it, because all of my x's would need to be twice as big, because the first thing I'm going to do is multiply them by 1/2. So if it's so strange because it's not intuitive, we wouldn't normally think this, but if you multiply by a number bigger than 1 in here, it's a compression. If you multiply by a fraction that's between 0 and 1, it's going to be a stretch. It would actually force all of my x's to be bigger to have that same effect. So it's a stretch horizontally, stretching that way. So really, it all depends on where are you multiplying? Where are you adding? Here, this, we're adding after I did the squaring. So this says, basically, they don't have parentheses here, but do the squaring first. Take that answer and triple it. So this causes my graph, which normally looks like this, it causes every y coordinate on this graph to be tripled. Every y coordinate is 3 times farther up. Well, 0, 0 is 3 times farther up. It doesn't move. Every point is shifted, is tripled. So what it causes is a really steep parabola. Okay, this would be a vertical stretch. If it was 1/3, some fraction there, take that y coordinate, take every y coordinate and multiply it by 1/3, that would be a vertical compression. And multiplying by a negative would cause a flip. The graph of this function, after a vertical stretch by a factor of 3. Okay, so for me, the thing that was tricky is I was thinking, we're doing a vertical stretch by a factor of 3. Vertical stretch means multiply. If it said vertical shift, then it would be adding. But this is multiplying by a factor of 3. So here's what I put originally. 3 times f of x. Boom. There, you're done. So that's not what they were asking for. They wanted to actually, for me to do the algebra. So I did 3 times that expression there. So it was 3 times 2x squared plus 5, which ended up being 6x squared plus 15. That is what they're looking for this kind of a function. I thought function rule, I'm in pretty good shape, but it wasn't the answer they were looking for. What transformation takes a graph of this, x squared minus 4, by the way, it's a normal parabola, shifted down 4 units, shifted because it's added and subtracted, to the graph of this? The only change they made is they replaced my x's with x plus 3's. So what happens when you replace all your x's with x plus 3's? Well, 0, negative 4 is on the graph when I plug in 0 for x. Well, now, in order to get that same point, I need to plug in negative 3 for x to make this 0. It forces all of my x values to be 3 less than what they were before to end up having the same result. 3, -4 is on the new graph. If we were to graph x squared minus 4, if you use Desmos, x squared minus 4 and x plus 3 squared minus 4, here's x squared minus 4, and I'm not drawing the axes, and here is x squared, x plus 3 squared minus 4. It's shifted 3 to the left. Translation, for sure not a stretch, right? Because it's adding or subtracting, we would use the word shift or translate. So here we have, suppose a quadratic function here, we have 1/2 x minus 3 squared plus 5 is transformed to this. So notice they have the same stretch factor. So this is going to be a rigid transformation. It's not actually changing the steepness. So before I used to plug in x equals 3 to get 0 here. Now I need to plug in x equals 6 to get a 0 here. So I used to plug in 3, now I plug in 6. Basically, I have to plug in a number that was 3 greater than the other number. If I plug in 1 here, I get 1 minus 3 is -2 squared. I need to plug in 4 here. Every x coordinate is 3 bigger on this new graph. So it is shifted to the right 3 units. So I don't have to do anything more, actually. I already know the answer. But I know it's shifted up 2 because I used to add 5 to this result. Now I'm only adding 3 to this result. So it has a result of shifting this graph down 2 units because I'm not shifting up 5 anymore. I'm only shifting up 3. So it causes my parabola to be shifted down 3. And by the way, you can use Desmos to help you with this. And we have 2 more here. So suppose the x coordinate, that this is transformed to this. Notice what change was made. They replaced x squared with 1/2. Let's cut x in half, then square it. So this forces all of my x values to be twice as big as they used to be. All my x's x coords need to be twice as big to have the same effect, be twice as big. So it forces the normal graph, which might look like this, it forces it, all my x's are bigger. They all have to be bigger because the first thing I'm going to do is cut them in half and then square. So it stretches them, compressed. Okay, and why isn't it vertically? It's not vertically because I'm doing it to the x. So I know for sure vertical is not going to be the answer choice. So now I'm down to 50-50, yay. And this one is it compressed? Compressed would mean this way. Stretched would mean this way. And nobody would ever say, in their right mind would say, oh, it's stretched horizontally by a factor of 2. You would say, oh, wait, there's a 1/2 here. It's got to be the 1/2, but that's not what's happening. It's not compressed horizontally. It is stretched horizontally. I took this red graph and everything is, all my x coordinates are doubled. Same y coordinates, all the x coordinates are doubled. Okay, and finally, this one. This graph shows a parent graph, function f of x, labeled and g of x. So we have f of x and g of x. How? This looks like normal old f of x equals x squared. I'll just write it in there. So then how does this graph compare? It looks like it's moved 1, 2, 3 units to the left, 1, 2, 3, 4 units down. It looks like this is -3, -4. What is the equation in vertex form? In vertex form, it would be g of x equals squared plus or minus something. Well, if it's shifted down, it's minus. So this is -4. It's the changes that are made out here with y are actually easier to interpret. The ones in here are the trickier ones. So I moved it to the left 3. I actually have x plus 3 here because I used to plug in 0. Now I plug in -3 because all my x's, I added 3 to them and then I perform that same function. Okay, so this is the trickiest ones are the ones that happen in here, but you got some help for you. And you could test it using Desmos. If you did x minus 3 squared minus 4, because it's 3 in the x direction, 4 in the y direction, you were trying all 4 different combinations, you'd pretty quickly find, oh, this is what I need to do to get that orange graph. All right, y'all. Good luck.